So today we're going to be looking at the binomial theorem or Pascal's triangle when we expand polynomials. So last time I talked about the idea that we could take something like x plus 5 and cube it. And we could take it and do x plus 5, x plus 5, and x plus 5. And we can do this because that's what this cube means. Cube tells me that I'm multiplying the same thing times 3 times. So remember, you can't just bring it inside, and I can't do that here because of that addition in the middle there. If it was multiplication, we could, but because of that addition, we have to be very careful. And then you would take these, and I'll show you this in a second, we take these, multiply them out, and then we would take whatever we got from that and multiply it to the last one. So let's do it the long way first, and then I'm going to show you the shortcut. Excuse me. So looking at letter A here, I'm going to start with x plus 1. And again, I can rewrite this, and I prefer to write it this way. So what we're going to do is we're going to take these last two, and it's the same thing because multiplication is commutative. We're going to multiply those out. So throwing it in the box from last time, x1, x1, x squared, x, and 1. So then I have x squared plus 2x plus 1. Okay, and then I would take that and multiply a binomial times a trinomial. So x squared, 2x, 1, x1, x cubed, 2x squared coming from x times 2x, x squared, 2x, and 1. So adding that all together, I get x cubed plus, we got 2x squareds here, so 3x squared, plus 3x, plus 1. Okay, and it's already in standard form for me, so I don't need to necessarily do this last step. So the idea here is we're gonna take those, and we could do this any number of times. We could do it 4 times, we could do it 5 times, we could do it 6 times. But once we start getting, especially like 4, 5, and 6, this starts taking a while because you're having to do the box several times, and the box is getting bigger each time because now I have a 4-term polynomial, right? And so the next step would be a 4 by 2, okay? And then it'd be a 5 by 2, and then a 6 by 2, and it just keeps getting bigger and bigger and bigger. So what we found is if we take Pascal's triangle, and remember Pascal's triangle is this triangle right here. And what we do is ones always go down the sides, and then we add. Okay. If we take Pascal's triangle, we can use Pascal's triangle to expand these polynomials much quicker. Okay, so let's look at that. Okay, so first we're going to start, again, we got this nice pattern where as we go down the sides, we've got ones. And then we add, we get 2. Add, we get 3. 1 and 3, 4. 3 and 3, 6, so on. And then I can do this forever. Put 1s on the outsides. 1 plus 4 is 5. 4 plus 6 is 10. 10, 5. I can keep going. 1, 6, 15, 20, 15, 6, 1. And I can keep doing this forever and ever and ever. And what we're going to find here is that we can take these numbers and multiply them by the coefficients, and we end up with the row we need for based on the exponent. So what I want to do here is I want to be careful when I number these, and I'm going to use a different color here, and you should use one too, because these are not part of the triangle. These are kind of like the rows of the triangle. This is the 0 row. We're going to start with 0. Row 1, row 2, 3, 4, 5, and 6. Okay, and again, this goes on forever, but you shouldn't need beyond, at max 7 or 8. So how do we use this? Well, we're going to start with x minus 2 to the 5th power. Okay, first step, you want to go, excuse me, you want to figure out which row you want, okay? The row is always going to come from the exponent, okay? So row from the exponent. So going back, my fifth row is 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. Okay. The second thing we want to do is leave space. This is going to be very important. This is honestly one of those things that it takes up a lot of room on your paper, but the math behind it isn't really too intense. It's just a lot of space. Okay, so make sure you're leaving space for some numbers, some exponents. Like, leave yourself a decent amount of space, and I'll show you what I mean by that. Okay, so I'm going to take the row and rewrite it. So 1, 5, 10, 10, 5, 1. And I'm going to put parentheses around all these. Okay, so the idea here is that you really are going to want enough space for 3 sets of parentheses with a number in between them and a plus minus between all that. Okay, so, and you're going to put pluses on all these. From there, we've got 2 terms here. We've got basically an A term and a B term. I'm going to take the A term and I'm going to put it to the power of 5. Whatever my power is, I'm going to take the A term and do my power. So A term, I'm going to do the power, and then I'm going to count down. Okay, so what I mean by that is I'm going to take that A term, x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1, and then x to the 0. Okay, I'm going to take the B term and count up. And I'm going to count up from 0. So I'm basically flip-flopping these, okay? I've got this, this side starting at 5, going all the way down to 0. So I'm going to start at 0 and go all the way up to 5. So that B term, and this negative is important. -2 to the 0, -2 to the 1, -2 to the 2, -2 to the 3, -2 to the 4, -2 to the 5. Okay, now what we want to do is we want to combine like terms where we can. Okay, so any numbers without any variables, those are the easy ones. Okay, because really, and actually probably the better way to do this is to think of it as distributing. Because on the second one, I've got an A term and it's going to be 3y. And I'll show you that one in a second, or one that's similar. But because of that y, it's gonna mess with things, or the 3, it's gonna mess with things because I need to not only do the power to the y, I also need to do it to the number. So you gotta kind of distribute where needed. Okay, since I don't have any like coefficient in front of the x, I don't necessarily do that here. Okay, so I'm gonna take the 1, I'm gonna take the -2, I'm gonna put that in a calculator and let it do the work for me. Now keep in mind, anything with 0 power is just 1. Right? So this one and this one kind of go away. Okay, so let's start cleaning this up. I've got 1, x to the 5th. Here I've got a 5 and a -2 to the 1, so just -2. So 5 times -2 is -10, x to the 4th. For this next term, I've got 10 and -2 squared. -2 squared is going to be +4, so plus 40 x cubed plus -2 cubed is going to be -8, so actually it's a minus here, times 10 minus 80 x squared Here, negative 2 to the fourth is going to be positive 16 times 5. It's going to be 80 as well. Yes. And then just x. Okay, I don't really need that one. And then the last one, negative 2 to the fifth, 2, 4, 8, 16, 32. But it's going to be negative. Okay, and there's my answer. Again, I don't necessarily need this one out front, so let's get rid of that. Okay, now I could have taken this 5 times or 4 times and thrown it in the box 4 times, right? Because this is the same thing as x minus 2, x minus 2, x minus 2, x minus 2, x minus 2. I could have done this in the box, and then this in the box, and then this in the box, and then this in the box. Could have done that 4 times, but you'll see, especially once you get up into 5, 6, 7, and 8, that once you've done this a couple times, there's really nothing that's too challenging here. I'm taking the coefficients from Pascal's triangle, throwing them in. I'm taking all the A terms and counting down. I'm taking all the B terms and counting up. So really, it's the same thing. It's just, and then just combining the terms. And it's not anything that's really bad. You're just doing some basic PEMDAS here. And really, the calculator can do that for you, right? Like you could take this, especially on this one, and throw it in the calculator, and then you're done. So let's look at one though where the number is a coefficient. Okay, so we're gonna do this one. It's gonna work the same way. So my first step again was to find my row. So I'm looking for the 5th row. So it's going to be the same. So 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Okay, I'm going to take those A terms and count down after I put these in parentheses. So 2t to the 5th, 2t to the 4th, 2t to the 3rd, 2t squared, 2t to the 1, which is really just itself. And then on that last term again, I would have 2t to the 0, but anything to the 0 power is just 1, and I'm just multiplying by 1, so it really doesn't do anything. So you don't really need to do that 0 term unless you really want to. So for the first one, again, so for b, we're going to count up. So it would be minus 1 to the 0. Again, doesn't really do anything. So minus 1 to the 1, minus 1 to the 2, minus 1 to the 3, minus 1 to the 4, and minus 1 to the 5. Okay, and these are all plus between for right now. Okay, so this is where I do need to be careful because I'm really going to distribute these exponents onto the 2 and the t. And I can do that here because there's no addition or subtraction. Okay, this is just multiplication, 2 times t. Okay, I can't do it on the original equation because there's that subtraction. Okay, so that's an important distinction, something to be very, very careful of. I've seen a lot of students who will just take the 5, put it on the 2t, take the 5, put it on the negative 1, and that is wrong. Okay, so I'm taking that 5, I'm applying it to all the parts. Okay, so I can start getting rid of parentheses here. 1 times, actually let's not get rid of parentheses yet. And then 2 to the 5th, t to the 5th, plus 5, 2 to the 4th, t to the 4th, minus 1, again to that 1, but we don't really need the 1, plus 10, 2 to the 3rd, t squared, sorry, 3rd, negative 1 squared, plus 10, 2 squared, t squared, negative 1 to the third. Okay, and again, this is kind of where it gets tedious, and it's a lot of tracking, but as long as you're being precise, as long as you're being careful, you should be fine. And then negative 1 to the fourth plus 1, negative 1 to the fifth. Okay, so doing this term by term, do it one at a time, term by term. And really, if you want to do like this term first and then this term and just do it one by one too, at that step, that's fine too. Okay, so I'm going to look at this first term. I've got 1 times anything is just going to be that thing. 2 to the fifth is 16. T to the fifth. 5 times 2 to the fourth, and then this is going to turn it negative, that negative 1. So 2 to the fourth is 16 times 5. Give me 80. T to the fourth. Okay, sorry, it's going to be negative because of that negative on the negative 1. So negative 80 t to the fourth plus, okay, now this one's going to be positive because a negative times a negative gives me a positive. 10 times 8, 80 t cubed. Next term, 10 times 2 squared, which is going to be 4, so 40. Negative 1 to the third, negative times a negative is going to give me that negative. So it's going to be negative 40 t squared. 5 times 2 is just 10. Okay, and this is going to turn positive with that negative, so plus 10 t. And then negative 5 times is going to be minus 1. Okay, so here is my answer on that one. So just to ooh, let's not do that one. That one's huge. Let's do another fifth. Let's do this. Let's make our own, just so we can double check and see that we're doing what we need here. So insert page blank. There we go. Okay, so let's do one more. Let's go plus 4. And let's just go to the fourth power this time. So we're doing a different power. So looking at the fourth row, 1, 4, 6, 4, 1. So I'm going to write down my row. I'm going to count down my A's after I put parentheses. Counting down with A's, X. I'm going to start at the fourth. X cubed, X squared, X to the 1, which is just X, and then X to the 0, which is just 1, so I don't need it. Counting up, start with 0, so nothing. 4 to the 1, which is just 1, or just 4. 4 squared. 4 to the third, and 4 to the fourth, adding. Okay, now again, do this term by term. 1 x to the fourth is just going to be x to the fourth. 4 times 4 is 16. X cubed plus 4 squared is going to be 16. 16 times 6. 6, 3, 96. 4 cubed is 64, times another 4 is going to be 256x. And then 4 cubed, or 4 to the fourth, is also 256. Okay, so there's that lesson. Almost made it without pop-ups. So if you have any questions, again, make sure you're showing up for RTI Fridays. I am available for regulars between 10 and 12, and then 12:40 and 2:40 for honors students. Please do try, especially this is an honors topic, make sure you're coming for that honors session. I'm able to focus with you guys better if I'm able to disseminate the lessons better. So make sure you're showing up for the correct times. Make sure you are showing up if you're needing help. We also have the before and after school tutoring. You don't need to be here for either of those. There's Zoom links on my webpage for both. Please let me know if you have any questions, and see you next time.